So can you start with your introduction, please?
Yes, sir. Sir, my name is Gunula Venkatesh. I am from Hyderabad, Telangana state. I did my schooling in government school from Telangana state. After that, 10th CGPA, I got selected in one of the IIT in the Telangana state, which is IIT Basar in Basar district. So from there, I done with my +2 as well as B.Tech. So I did my graduation in electronics and communication in 2019 with 8.69 CGPA.
Okay, that's great. So you have done bachelor from which college?
IIT Basar, sir. IIT Basar. It is in Telangana state only.
Okay, so after completing your graduation from IIT, didn't you occur some campus placement?
Yes, sir. I got it. Actually, I got it in campus placement. But before that, I was preparing for third year itself, GATE and this research-oriented organization for that. So for that, the GATE is mandatory. I came to know that I prepared, but I couldn't make it. But unfortunately, I have to go for a job. So 2.5 years I worked over there. But I couldn't make it interest over there. Again, I resigned in the last year, 2022 in July. Again, I prepared for 6 months of this GATE and for this BARC every exam. But through GATE, I couldn't make it. But after that, there will be online exam. So I got with that for the interview for this one.
Okay, so what was your best rank in the GATE?
GATE 2450, sir.
Okay, 2415.
Yes, sir.
So why you want to join BARC?
Sir, actually, I want to go for core electronics related research oriented. So when I was in B.Tech, so many of them, when I was searching for these kind of related core and research oriented government related sector, there my seniors also, one of the ISRO scientists came and taken guidance for us, so that there will be 3 main sectors like ISRO, BARC and DRDO. So when I was started for GATE, there I came to know from GATE and very separate exam for every year the BARC will be conducting. So that I was giving for that, and because it was core and it was one of the precious institute in India, so I would like to go for that, sir.
Okay. So in bachelor, what are the subjects you are comfortable with?
Sir, electronic devices and circuits and analog electronics, digital electronics.
Okay. So what project you have done during your engineering?
Sir, in my engineering, I was done with the abnormal event in crowded scenes, sir. It was like MATLAB related and ML related.
Okay, so you know ML?
Not, sir, not much, but it was like mainly MATLAB tool. But ML is very not. It is like instruction related only.
Which algorithm you used of the ML?
Sorry, sir.
Which ML algorithm you used?
No, sir. There mostly we used only MATLAB related tools.
Okay, so it was solely done by you or some other people were also there?
No, it was group. Actually, initially we was started with 3 members, but in the starting, one of the guy got internship in the other company. He went, so we talked with professor and we were 2 were doing on that only.
Okay, what was the ultimate need of this project? What was the why you choose this research problem?
Actually, sir, when we are in crowded scene in that sense, like heavy people are there, railway stations or airport, there will be sometimes will be abnormal situations like it is like very rare cases, maybe like huge impact will be there, like bomb blast or some major accident or fire accident. Such times there should be some situation to know for higher authorities to emergency to come and take care of some sort of people to take emergency to the hospital or what emergency required. So that makes me to go with that.
Okay, what was your role in that project?
Actually, sir, throughout the paper.
Was it an experimental paper or was it just a literature review?
Sir, I didn't get you, sir. Can come.
Was it an experimental? You have made the experimental model for this, or it was just a theoretical paperwork?
No. Till now we didn't make any model, but it was like theoretical review finally. But in future required we can go, but we didn't go till that end.
And do you have any patent and publication for the same work?
We are previously, sir. Previously there was, sir.
Okay.
On that same.
Okay. So you are comfortable in the analog, right?
Yes, sir.
Okay. So in digital, you might have studied flip-flop, right?
Yes, sir.
What is the use of flip-flop?
Sir, flip-flop is it's a storage element, 1-bit storage element. So everywhere we are using for storage, there will be flip-flop will be there, sir, for storage purpose.
Okay, and you might have studied one schematic trigger in analog, right?
Yes, sir.
For what purpose we use this?
This is the majority times we will go for this any wave generation kind of thing, sir, like a square wave of any.
No, that I can do from any other also. That I can do from square wave converter. That I can do with zero crossing detector also. What is the specific use of this?
I think, sir, I know little bit only schematic trigger, but not really recognized.
Have you heard this term multi-vibrator?
Yes, sir.
What is multi-vibrator?
So multi-vibrator, it is oscillator. So which will be useful for generating some higher frequencies, which is used for these many of the frequencies.
See, what I know, we study three kind of multi-vibrator. A stable.
Yes, sir. Monostable.
We study monostable, right?
Yes, sir.
We study bistable. Can you define them? Can you differentiate them?
Yes, sir. A stable means there will be no specific stable state, sir, actually. So it will be running free running oscillator kind of thing. But whereas come to the monostable, there will be the only one specific stable state. When we give a triggering to that, then only comes to the again specific stable state. Again, it come back to the original normal state.
Can you give me any example of bistable?
Bistable, yes, sir. We can call flip-flop itself as a bistable.
Why it's a bistable?
Sir, we can store for 0 as well as 1. There will be 1 as a stable state. We can consider these two as well as both stable.
What is the meaning of that 0 is stable state, 1 is stable state? What is the meaning of this?
0 is nothing but high level we maintain. So when we require high level, it's a continuous time. We can store as a 1 as a in the.
No, I got your point. You are storing either 0, you are storing either 1. How you come to know that if it's storing 0, it's a stable state, right? How you come to know that if it's storing 1, it's a stable state? Only then you are saying that it's a bistable, right?
Yes, sir.
So how you can make sure that if it's storing 0, it's a stable state. If it's storing 1, it's a stable state. How you comment on that?
Actually, sir, stable state means whenever we require one state continuously. So in that, if we are able to keep it in that state, it is called stable state. I'm assuming. So
tell me from the flip-flop point of view. Okay, when we study about the flip-flop, do you have studied control input?
Yes, sir.
What are the control inputs? Can you give me some example?
The control inputs were for the clock. One is clock.
Clock is the control input.
Yes, sir.
How clock is the control input?
Sir, without clock, the flip-flop will not work, right? So whenever required, whatever the inputs or outputs we require, specific values, we will.
Okay, this is SR flip-flop, right? So this is S, this is R, this is some clock, right?
Yes,
so
sir.
out of, tell me, the output, it will be 0 or 1. Who will decide? Clock will decide or S or R will decide? Tell me.
Sir, actually depends on S and R only. But
my question is simple. If you have SR clock, the output will be 0 or 1. Who will control out of S and R output state? S and R control or clock control?
S and R will control, sir.
What will be control input then?
Sir, I told like my point of view, like without clock there won't be any output, right? Such that I thought like this way the controlling the clock. If there is no clock, the S and R we given also there is no use, right, sir?
But if there is no clock, if S and R have some preset value, at least according to that, the output is controlled. Na particular value is maintained there. Clock is a trigger input.
Yes, sir. There will be, sir, there will also 2 more control inputs actually. So I told clock may be not correct, but there will be again preset and clear also. There will be.
They are a synchronous input. They are not control input.
Okay, sir. Maybe I mistaken.
Okay. Have you studied the setup time and hold time?
Yes, sir. I know just definition, but detail not.
Why these are important?
Sir,
why we need to take these into consideration while studying the flip-flop?
So these are required because setup time tells that before the clock, how much time they should be the limit so that it will be the stable.
Oh, that I understand, but why they are required? That I understand. You will be defining the definition. Okay.
Yes, sir. But in depth, I'm also not sure that. But I was going through that, but I didn't get much videos on that.
Okay, if I ask you to categorize chemical trigger, that whether it's a stable, whether it's a monostable, bistable, what you will tell?
So I think stable, but not sure 100%.
Why a stable?
Right. It is like it will work like any input. It will give is like a square wave or it is pre-running oscillator. So there will be no specific stable state will be there.
It have two state, plus VSET, minus VSET, right?
Yes, sir.
Transition from plus VSET to minus VSET and from minus VSET to plus VSET, when it happens? When your input crosses the threshold, right?
Yes, sir.
Is it clear? So
Yes,
then it will be a stable. A stable means transition is happening itself without any input. But the plus VSET to minus VSET, minus VSET to plus VSET transition is only happening when your input is basically crossing the threshold level. Am I right or not? Then how it can be a stable?
Maybe, sir, I'm not sure on that. But I thought like with okay, reference is there, but it was going like without any our information, right? So plus VSAT, minus VSAT, something like that. But I thought like that.
Okay, we talk about the comparator, right?
Yes, sir.
So I'm giving you two cases. One is the single threshold comparator, right?
Okay.
And one is the double threshold comparator, okay? Which you will prefer in the industrial application, single or double?
So actually, I know that single threshold comparator only. Till now, I am not sure about double threshold, but industry level, maybe there will be advanced double level thresholds. I'm not sure.
Have you studied schema trigger?
Yes, sir. But
isn't it a double threshold detector? We have the upper threshold, lower threshold.
Okay, sir. So plus VSAT and something like that.
We have the upper, lower threshold and upper threshold. Yes or no?
Yes, sir.
Isn't it a double threshold?
Okay, sir. Okay. So I think that now industries use double threshold, I think.
Why you would prefer double threshold?
Specifically, I'm not sure, but I'm guessing because it will be two thresholds, no? So maybe multi advantages there will be, but I'm really not sure.
Okay. See, we talk about analog signal, we talk about digital, right? So can you tell me in the process A to D conversion, what are the different stages? I'm not asking any particular converter, right? If I give you analog signal and in the digital signal, what are the stages you will follow? What are the steps you will follow?
Sir, initially there will be the sampling and hold circuit, which will sample the analog signal to the discrete signal.
Sample and hold circuit. Do you know sample and hold circuit, how to draw it?
Yes, sir.
Draw it.
Or something like this. I mentioned there is switch, but I did not specify any.
So for what purpose you are using this?
For sampling purpose, sir. For initially for analog signal to we have to sample.
Okay, you have drawn something like this, right? You have drawn something like this. Am I right?
Yes, sir.
Right?
Yes, sir.
So this is switch, right? So this obviously you are drawing on the copy with a pen. That's why you're drawing the switch. But practically, if I ask you to implement this in the lab, okay,
yes,
on breadboard or some software or any designing tool, is it clear what you will use here? Which device you will use here?
I think, sir, MOSFET we can use.
Why not BJT?
BJT also we can use, but MOSFET is more preferable than.
Why MOSFET? Then why MOSFET?
It is a very good switching capability, no, sir.
On what parameters?
Sir,
If I'm saying Gurnala Venkatesh is a very good person, it means there are some characteristics.
no,
Right?
like not like yes, sir. There should be some characteristics for
What are those characteristics?
So MOSFET has a high speed device compared to BJT, so it can switch within short span of time for switches more suitable.
Okay, Venkatesh, let me summarize, then Chandra sir will start. Okay, so very first thing is that you have few knowledge, but sometime at the same time you do some silly mistakes, right? You are giving answers very casually. See, first you must know what is the meaning of astable, bistable, monostable. See, I'm not saying that this question will be asked there. Okay, it's just a situation framing. You told me flip-flop. So you must be very clear with flip-flop. What is the clock? What are the synchronous input? What are the synchronous input? What is the control input? What is the trigger input, right? And you must be doing in very detail their sample time, hold time importance, clock time. See, most flip-flop you draw as a symbol. Internally, it contains various electronics component, right? And each electronics component takes some time to process, right? So it's not like that you just applied the clock and you just applied the data. Whatever data you are applying, there must be a minimal time that should be allowed for the data so that the system can take its processing time, which in relevant language we talk the time constant, right? So that it can process the given information effectively so that there is no false triggering. I just want to open why you are answering me right, setup time, whole time. See what I see sometime that how instantaneously you can think in a random direction. That is required basically for this kind of interview, and that too in the relevant point of view, not in the irrelevant. Is it clear?
Yes.
Now, when I ask you to draw the A to D converter, simply say, sir, in A to D converter, very first stage should be our sampling, then quantization, then encoding. Is it clear? These are the steps you will follow. Sampled and hold circuit specifically, you don't need to discuss because it's particularly used for the sampling, as you have used the switch. Is it clear? And then obviously, whenever we do switching, we mostly prefer the MOS devices. Is it clear? So you discuss about the speed and all, but try to sharp more in that direction. Is it clear? And most of the time we always prefer the double threshold comparison. Reason being, industry there might be noise, some external disadvantage, some external distortion, because of which sometimes there might be ripple on the amplitude. So if we are using the double threshold comparison, so definitely we have that gap between the upper threshold and lower threshold within which variation can be tolerated without any transition in the output, right? So that's why we mostly prefer the double threshold comparison. And flip-flop, you told me the right example of the bistable, but at the same time, you were not able to convince. Somewhere you were 70-80% right. See, if I'm asking you why it's a stable, why you're saying that 0 is stable, 1 is stable, then you simply tell us, sir, if it's storing 0, then it will keep on storing 0 until or unless it's not triggered externally. It means it's not shifting its state at its own, right? We need to give some external signal to shift its states. So that is a basically stability, or indirectly the same definition of stability you just studied in the control system. But the meaning we have changed, we have converted those in terms of the system analysis, right? But if I'm telling you are a stable person, it means if you are stable at your position, you will not change yourself. You need somebody external source to change your state of mind. Is it clear or not, right?
Yes,
So
sir.
there are answers which can relate with the practical things, whatever is existing in the real world. Okay. So
Yes.
next, basically, I guess Chandra sir will continue with chance. Please continue, sir.
Yeah. Hello, Venkatesh.
Good afternoon, sir.
Good afternoon, Venkatesh. Fine. So let's take one RC circuit,
Yes, sir.
RC series circuit, and give the input as impulse voltage source.
Okay, sir.
Impulse del of t you give.
Okay.
So can I get voltage across capacitor? Or you draw the circuit for t greater than 0, first of all.
Sir, output circuit for t greater than 0.
No. You draw the circuit for t greater than 0.
Okay. Sir, for t greater than 0, I need to draw circuit again, or
Again,
L of t
L of t is the input voltage source. Okay. I'm asking you to draw the circuit for t greater than 0.
So what I'm thinking this, it will be open switch because
Why open circuit?
for the adaptive works at t equal to 0 as a source, but t greater than 0, don't know, it will be
It
like.
is absent, right?
Yes.
So if voltage source is absent, we have to replace that one with the open circuit or short circuit.
No, yes, sure, sir. It will be short circuit. It will be short circuit.
Okay. What is the voltage across capacitor before t is equal to 0?
Before
I given an empty capacitor to you.
Sorry, sir.
I given an empty capacitor to you.
Okay.
What is the voltage across capacitor for t greater than 0?
T greater than 0.
Yeah, sorry, t less than 0.
T less than 0. With the del of t as a voltage source.
Yeah.
Even though it is 0, sir, I think. At
Okay,
t less than 0
For
and
t greater than 0, how much it is?
sorry, sir.
For t greater than 0.
T greater than 0, I'm thinking it is 0. At t equal to 0 only it will work, I think.
So what is happening at t is equal to 0? Can you explain?
So for t equal to 0, sir, it is a impulse signal. It will be t equal to 0 only exists, no, sir. So that is the reason I'm thinking, but I'm really not sure whether it will be stay after the t equal to 0 or less than t equal to 0, the capacitor value stored.
Okay. So do you know that capacitor does not allow sudden change in its voltage?
Yes, sir.
If it is required to get the sudden change of voltage across capacitor, what I have to do?
Input should be the impulse, sir. For impulse only the changes across the capacitor will be happening.
We given impulse inputs right here.
Yes, sir.
Can I expect sudden change of voltage across capacitor? Is it happening?
I think, sir, it should happen, but I'm not sure how to express. I just read that it.
Can you write its KVL equation? That circuit KVL equation?
Yes, sir. This one. Is it box right?
Okay. So from that, can you get current? Expression for current.
Yes, sir.
Fine, you should not take this much time, man. If it is becoming difficult for you in time domain, go with the other domain. You know what is other domain that can be taken for finding currents and voltage and network analysis, right?
Yes, sir. Okay. Sir, I got it in frequency domain, Laplace transform, but again need to be converted into the.
Convert it. How much time it take? Inverse Laplace. It is not more than it will take 10 seconds, right? Partial fractions and then inverse Laplace. You know the simplest thing I asked. So you're taking too much time, Venkatesh.
Yes, sir. 1 second. I'm getting something like this, sir. -1 by C power T by CPT.
Okay, fine. Let's. What is time constant, Venkatesh?
Time constant.
General definition of time constant. What you understood by time constant?
So actually, it is the equivalent of for RC circuit. It is a RN
For
equivalent.
that circuit, I'm not asking. Generalized way of understanding time constant. Okay, fine. So we know that the capacitor does not allow sudden change across its voltage. Why it is so?
No, sir. It will try to recollect the whatever the previous voltage. That will only the regains in that.
Why it is doing? Why it is happening so? Can you explain by taking some concepts or what you understood from that?
At the moment, I'm not getting anything.
Okay, fine. Take one signal. I of t is equal to I m sin omega t.
I have T equal to?
I m sin omega t.
Okay.
If I increase omega,
Okay.
suppose if omega is tending towards infinite,
Okay.
so it's very high. Okay, can you draw the waveform?
So frequency versus I or
Omega t versus I.
frequency tending to infinity, right, sir?
Yes, very high.
It is ranging from 0 to infinite, something like that I can assume. Or
No, I'm not saying that it is ranging from 0 to infinity. It is very high. Okay, if 0 it is, it's a DC signal. In fact, that will be 0. I am sin omega t of plus theta if I take, okay, it is a DC signal. It is going to have some magnitude, right?
yes, sir.
So my omega is very, very, very high. Can you draw? Can you draw first of all? F is equal to 1 hertz. Frequency is equal to 1 hertz. By taking frequency is equal to 1 hertz, you draw the waveform of that sinusoidal waveform. Take sin omega t, in which frequency is equal to 1 hertz. Simply omega equal to 2 pi. 1 hertz. It is 2 pi. Draw its waveform.
Something like this, sir.
So make it a 2 hertz frequency now. On the same reference you draw.
Below 1.
No, I told you. What is the difference then?
This is time period, sir. Time period will be the difference.
Okay. In the same time period, how many cycles you are getting in physical 2
2.
hertz?
Second one, we are getting 2 cycles. First,
Suppose I am increasing towards frequency f towards infinite, then tell me. Then can you draw?
I think, no, sir, but there will be infinite cycles in the one period time.
So I'm not taking ideally to take infinite. If it is very high, then how the graph looks? Fine, okay, let's leave it.
Yes, sir.
See, why Bode plot is drawn on semi-log sheet?
Sorry, sir.
Why Bode plot is drawn on semi-log sheet?
No, sir, I am not gone through the control system basics. I mean, I am not prepared these days.
So how much is one bell? One bell.
One bell.
So I think in communications you might study about gains, power gains in terms of decibels, right? I need one bell, not decibel. I need one bell. How much is one bell? How to find one bell? My input power is Pi, output power is P naught. I want the power gain to be in bells. So how to find?
No, sir, I heard decibels, but not bell. Bell I'm listening first time.
So what is the difference between bell and decibel?
No idea, sir, actually.
Fine, let me give you feedback on this.
Yes, sir.
I think all the questions I asked were very basics, man. Okay. See, bell means 10 log, sorry, log of P naught by Pi is 1 bell.
Only log, not 10.
Only log. Deci means multiplication with 10. 10 log P naught by Pi is decibel.
Okay.
dB.
Yes, sir.
So I asked very basic questions, man. Okay. So when is your interview?
31st, sir.
31st. Okay, fine. Fine. All the best from my side. But try to focus on the basics. Okay. See, it is very much needed fundamentals of all the subjects in engineering, at least your core subjects, like control systems, network analysis. See, without having knowledge in network analysis, if you say that you are good at analog electronics, it's not a correct thing. One must have good knowledge from networks. See, application of networks, say analog, you are studying with the application of networks only, right?
Yes,
You are
sir.
studying about high frequency modeling of BJT, right? Yes. So must have basics and a deep knowledge in at least 4 subjects is very much important. 1, 2, 3 subjects are not sufficient for BARC, right?
Sir, my doubt is actually I came through across these two or three times in the interview. I couldn't able to explain actually this capacitor, how it will not, why it will not change.
Fine, I'll tell you.
Yeah.
See, what is energy storage of capacitor formula? Energy storage capacitor.
Half CV square.
So energy of a capacitor is exclusively depending upon what? Half is constant, C is constant, right?
Yes, sir, voltage.
Voltage square, right? So you tell me, does any energy in this world will change suddenly? Suppose sudden means within 0 time. Please do understand the point that sudden means within 0 time. Suppose if a fan is running, so in 2 ways I'll explain. One is from physics, another one is from mathematics, right?
Okay.
Your fan is running in the room. If you switch it off, it will take some time or not for the fan to stop.
Will take some time.
Why it will take some time? Because it's already having some kinetic energy in the rotor.
Okay.
It attains some energy, right?
Yes, sir.
So from physics, a very clear point is energy either to increase or decrease. Suddenly it will not happen, it will take some time. From physics, any energy you take. You are running very fast. If I ask you to stop suddenly, will you stop? Sudden means within 0 time. Please make that. If you understand sudden means within 0 time, then only you can understand. Okay, within 0 time, energy change will not take place.
Okay, sir.
Right. So the first point is capacitor does not allow sudden change in its energy. Right. Inductor also does not allow sudden change in its energy. Energy of a capacitor is exclusively depending on voltage. For the voltage to change suddenly, energy change should happen suddenly, which is not possible. That's why voltage across capacitor will not change suddenly. This is from physics. But another way of understanding from mathematics is, what is voltage across capacitor formula? V equal to 1 by C integral I of t dt, right?
Yes, sir.
So sudden means from where to where I have to take the integration limits from 0 to 0, right?
Yes, sir.
Any signal integration, any I of t, integration from 0 to 0 is 0, right?
0. Yes, sir.
Except that impulse, right? Only impulse can have that. I of t is equal to del of t, then only voltage across capacitor will change suddenly, right? That's the reason why impulse signal can change, but ideal impulse is not practically possible, right?
Yes, sir.
Yeah, please.
Okay, sir. For impulse, it will change. No, for impulse, how means what I have to tell? This one is reason assumption. For impulse, only the existence of.
Yes, only impulse can make sudden change of energy.
Because
See, the impulse itself is a signal whose magnitude is infinite and whose width is equal to 0. Ideal impulse at t is equal to 0. If you take del of t, right?
yes.
You got the point?
Yes, sir.
See, Venkatesh, I suggest you please concentrate on the basics. BARC is about your basics and your thought process and thinking capacity. Whether you are able to solve a problem, new way. See, gate coaching, academics, all this will go in one direction. But BARC, interview or ISRO or DRDO will go in another direction. So you'll feel like, okay, why I did not talk this way when I'm studying. So that type of questions will be asked in BARC. Right?
Yes, sir.
So all the best from my side here.
Thank you very much, sir.
Venkatesh, you can leave this platform.
Yes, sir. Okay, sir. Thank you very much.